Now, we talked about, is there anything unusual? Is there any outliers? Well, what is an outlier? Well, that's a data point that doesn't fit the rest of the set. It's a data point that lies way out there somewhere. Well, how far out there is far enough to be an outlier? Well, that's kind of arbitrary. To me, I would say, oh, yeah, well, look at the 9 and 10 are outliers. They don't fit. They don't look like they fit the rest of the data. And you'd say, oh, they're not that far away. Well, they're not really outliers in my view. So we need a rule as to what technically is an outlier and how we would find one. So what we're going to use is something called the interquartile range to figure out what an outlier is for our formula for outliers. So you can see, here's some more red here. This formula in the book, this IQR, just ignore it and look what's in the white box here. So here's the formula for interquartile range, or IQR. It's Q3 minus Q1. It's the distance between the third quartile and the first quartile. So if I erase all my chicken scratch up here again, we said that Q1 was at 1. It's like somewhere in here. And we said that, oops, it should be over one more for this. And then we said that Q3 was at 4.5. The IQR is the distance here. How far is it from 1 to 4.5? Oh, the IQR is equal to Q3 minus Q1. So my IQR for this problem is 3.5. That is the distance from Q3 to Q1. Now, we need to be able to identify, are there any outliers? And here's the rule. Any number less than Q1 minus 1.5 times the IQR, or any number larger than Q3 plus 1.5 times the IQR would be considered an outlier. So let's do that. We know the IQR for this problem is 3.5. We know that Q1 is 1, and we know that Q3 is 4.5. So I need to find 1.5 times the IQR. So do I have any low outliers, any outliers on the low side? So if there is a number that is smaller than Q1 minus 1.5 times the IQR, well, let's see. Q1, oh, that's 1, minus 1.5 times the IQR of 3.5. When I do this work, I get negative 4.25. Are there any numbers here smaller than negative 4.25? No. So I have no low outliers. Well, we discussed before that maybe 9 and 10, to me, 9 and 10 didn't look like they fit the rest of the data set. To me, they looked like they were an outlier. Well, let's see if we have a high outlier. So you are an outlier on the high side if you are greater than Q3 plus 1.5 times the IQR. So Q3 is 4.5 plus 1.5 times the IQR of 3.5. So that gives us a value of 9.75. Do I have any numbers greater than 9.75? Oh, yeah, I do. So in this case, 10 would be considered an outlier by this how to identify outliers using the IQR rule. So remember, you said, no, I don't think any of them are outliers. I said, yeah, I think 9 and 10 are outliers. Well, neither one of us were right. 9's not an outlier because it is less than 9.75. But 10 is an outlier because it's greater than Q3 plus 1.5 times the IQR. Now, these data points that we're gathering here, Q1, Q3, IQR, all this stuff is going to be very helpful for the last type of graph that we're going to look at today, which is a box plot. Okay? The box plot requires us to use the 5-number summary. What is the 5-number summary? It's the minimum, Q1, median, Q3, and maximum. So in a box plot, we're going to make an x-axis. We're going to label the numbers down here, and we are going to plot the 5-number summary. So we're going to have minimum. We're going to have Q1. We're going to have median. We're going to have Q3. And we're going to have maximum. Box, whiskers. Okay? So that's what, in general, a box plot is going to look like. To make a box plot, we must have the 5-number summary, which is listed here. 5-number summary: min, Q1, median, Q3, max. Okay. So how do we make a box plot? Just like we showed here. However, there's something called a modified box plot. So if we have outliers, we have to show them in the modified box plot. The regular box plot does not show outliers, but a modified box plot will. Okay? And it looks like our book's not going to make that distinction. So all of our box plots are going to be modified, okay? Because we want to see as much information as possible. Remember, when we meet a set of data, we need to see what does it look like. Describe it visually, and then describe it numerically. Shape, center, spread, anything weird? Okay, so this is another way for us to do that. So we have a problem over here on the right-hand side. Students purchased pumpkins for the carving contest. Before they carved them, they weighed them. The weights were shown here. So let's try to make a box plot of this data set. So let's go to our calculator and let's put in all of the data into a list. So I have already done this beforehand. So if I go stat edit, I put all the numbers in the list. Well, to make a box plot, I need the 5-number summary. Well, lucky for us, the calculator will do it for us. So if you go to stat, calc, 1 variable stats, yep, please do the work for me in list 1, and I hit calculate. Look, it gives me the mean, X bar. It gives me the summation of X. So if I add all those numbers together, I get 228.5. It gives me the standard deviation, which is about 8. It gives me in how many data points there are. The minimum, the lightest pumpkin was 2. And if I scroll down here, it'll give me the rest of the information. So you notice here, it's giving us the 5-number summary. The minimum was 2. Q1 was 4, median was 6.6, Q3 was 12.7, and so on. So I know now that my 5-number summary is 2, 4, 6.6, 12.7, and 33. Now, how can I use that to construct my box plot? Well, I can't see that anymore. Why not? Weird. So let me write that data down underneath instead of up above so that I have it to finish this example. For whatever reason, I can't see that up there. So let me clear this off and we'll put that data somewhere else. All right, cool. So we had a minimum of 2, a Q1 of 4, a median of 6.6, a Q3 of 12.7, and a max of 33. So I had min, Q1, median, Q3, and max. Cool, let's use that data now to construct the box plot. So I can see that my values are going to go from 2 to 33. So when I make the box plot, my x-axis, I need to figure out what my intervals are going to be. And what do I need? So let's see, I need to go probably from 0 to 35. Maybe if I go by 5s, 0, 5, 10, 15, 20, 25, 30, 35. I just kind of looked at that in my head and said, well, what do I need to go by? And that's what you'll have to do to make your x-axis. So first, find the 5-number summary. We've done that. Identify any outliers. Whoops, we didn't do that yet. So are there any outliers in this data set? So an outlier would be any number less than Q1 minus 1.5 times my IQR. So what is my IQR? For this problem, my IQR is 12.7 minus 4. So my IQR is 8.7. So is there any number in this data set up here that is smaller than 4 minus 1.5 times 8.7? No, there are no low outliers. Are there any numbers in this data set up here larger than 12.7 plus 1.5 times 8.7? Well, that I don't know. So let's do the quick calculation here. I'm going to go back to my main screen and I'm going to try to figure this out. So it's 1.5 times 8.7. Now I need to do 12.7 plus that number. So any number bigger than 25.75 is an outlier. Any number larger than 25.75. So do I have any numbers larger than 25.75? I do. I have two values that are larger than that. Okay, so I have two high outliers. Okay, then they tell us, yep, I identified, I got two outliers. Draw and label the axes. Okay. What is this that we're measuring here? Oh, that's pumpkin weight. Scale the axes. Well, we did 0, 5, 10, 15, 20. Okay. Draw a box that spans the first quartile and the third quartile. I'm going to change the color up real quick so it shows up better. Q1 was at 4. Q3 was at 12.7. Okay. Mark the median. Oh, the median was at 6.6. Draw whiskers, lines that extend from the ends of the box to the smallest and largest data values that are not outliers. Okay, so my smallest value that's not an outlier is 2. My largest value that is not an outlier is 15. That's the largest number that's not an outlier. So that's how we know to get the whiskers. Okay? And then using stars or asterisks, show any outliers. Yeah, I did have an outlier out here at 31 and another one at 33. So it's showing the outliers. So this would be the modified box plot. Now from this plot, I can tell that the data is clearly right skewed. I can, if I want to use the median as the center, I can tell you that the center of the data set is at 6.6. I can tell you that the spread goes all the way from 2 to 33. And there's 2 unusual points on the high side, really heavy pumpkins. Okay. Let's take a look at our trusty calculator again, because it will do this plot for us. This is pretty slick. I think you guys are really going to like this because it's going to make things much easier for you. So remember in here in stat edit, I have all my data in a list. Now, the graph that we're going to use is stat plot. And this can make a modified box plot for me. So you notice when I go down here, I have it turned on and I go over to the box plot with the little dots and I hit enter. Okay, cool, it's going to make it. And then it says, where'd you put the data? Oh, I put in list 1, and then we tell it graph. Uh-oh, I can't see it. It doesn't show me a whole lot. So remember, for us, it's always stat zoom. Zoom 9, zoom stat. Hey, check that out. That's the same graph that we made over here. Now, the calculator did all the work for us. If I would like to know the values of these, I can hit trace. And it tells me minimum is Q1, and then I arrow over. Or I'm sorry, minimum is 2. I arrow over. Q1, oh, that's 4. I arrow over. Median, oh, that's 6.6. I arrow over. Q3, oh, that's 12.7. I go over again. That dot stopped at 15. That's the largest value that's not an outlier. I arrow over. Oh, my first outlier on the high side is 31. I go one more time, and my second outlier on the high side is 33. Box plots, get familiar with them. We're going to be making these over and over and over again. It's going to be very important for us that we can deal with these box plots. Whew. And we are done with chapter 1. It took us forever.